Let's continue with the Kahoot. Let's move on to the third question. Excellent job, you guys. Remember, when it comes to molecular compounds, we are not going to be dividing the subscripts. So I love to see that all of the students here understand clearly that the number of atoms for a molecular compound is determined by the prefixes that we utilize in the name. Please never, ever, ever divide those subscripts, even if they have a common denominator, because in covalent compounds, we do not do that. That is only for ionic compounds, and that was a topic from exam 1. Let's continue. There you go. Great job, Marisol. 3 in a row. Let's continue. Okay, you guys. So I want to stress to you guys that when it comes to the study guide, in the study guide, I gave you guys a table that has some common names for some common names for molecular compounds. You must know it. In there, you will see that N2H4 is hydrazine. So make sure that you know the common names for the other ones that are part of that table. You have phosphine, you have ammonia, you have water, you have nitric oxide, you have nitrous oxide. Make sure that you have that table handy for the exam, okay? Let's continue. Let's move on now to question 5. There you go. 4 in a row for Liz. Great job. Okay, so I see that a number of students didn't answer or it got this incorrectly. Let's actually go over this question. Okay, so for the exam, when it comes to the math that you guys need to be familiar with, remember that we only learn in this class that you guys can do the following conversions. You can go from grams and convert them to moles and vice versa. You can go from moles and convert it to atoms in the case of elements, or molecules if we're talking about compounds. Okay? So when it comes to this, we have certain conversion factors that we can utilize for converting in between these units. Okay? So what is the conversion factor if I'm trying to go from grams to moles? Let's put it in the chat. What is the conversion factor if I'm trying to convert? You need to divide, yes, I agree, but what? Thank you, Marisol. Molar mass. And like Vanessa said, when we're going from grams to moles, we are going to divide by the molar mass. And if we're going from moles to grams, we are going to multiply by the molar mass. Okay? Now, what about if we're trying to convert from moles to atoms? What is our conversion factor? Anyone? Let's put it in the chat. What is our conversion factor? There you go. Great job. Avogadro's number. Thank you, guys. So we're going to utilize Avogadro's number. And remember that Avogadro's number is 6.022 times 10 to the power 23. And remember that the unit for that is going to be atoms in the case of elements, like what we have in this problem, or molecules if we are talking about a compound. And like it was said on the chat, if we're going from moles to atoms, okay? Specifically, we are going to multiply by Avogadro's number. If we're going from atoms or molecules to moles, we're going to divide by Avogadro's number. So in the problem that we had here, it was given to us that we have 1.28 times 10 to the 25 atoms of copper. And what we needed to find was moles of copper. So taking that into consideration, what do we need to do? Multiply by Avogadro's number or divide by Avogadro's number? Great, divide. So we will say 6.022 times 10 to the 23rd atoms of copper per mole of copper. When we do that, then the units of atoms of copper cancel each other and everything is in moles of copper. And that's where the 21.3 comes from. Remember that in these problems, you guys, you must, rounding is not going to be set. Like the problem is not going to tell you, hey, round to this many sig figs. Rounding is implied, and expressing it in the correct number of significant figures is implied, okay? So make sure that when you are taking the exam, you follow the format for how to enter the answers. Unless you are in a multiple choice, then select the correct letter, okay? Put a 1 in the chat if now the problem 5 in the review makes sense. Great. Then let's continue. There you go, Nikki. Great job. 5 in a row. Let's continue. Let's move on to question 6. Okay, so here I'm kind of like, oh yeah, half and half. So 5 students got it correctly, the other students didn't. So you were given moles of a compound, which is hydroxylamine. And we needed to find molecules of hydroxylamine. So let me share my screen. So we solidified this concept because I want you guys to get this in the exam. So, as we discussed, you are given moles of hydroxylamine. I need a volunteer or volunteers that write on the chat, what is the chemical formula of hydroxylamine? Let me just make sure that people know. What is the chemical formula of hydroxylamine? Close. You're missing an atom. There you go. Thank you, Nikki. No, it was Isaiah wrote it and Katie. Great job, you guys. NH2OH. Now, we were given a compound. The question was how many molecules we have. Okay, So if we're given moles and we need to find molecules, our conversion factor is, let's put it in the chat. What is our conversion factor? Thank you, exactly, Avogadro's number, okay? Now, what are we gonna do with Avogadro's number? Are we gonna divide or multiply? Look at the at what we have up there. Excellent. We're going to multiply by Avogadro's number. And why are we multiplying? Because remember that units always in dimensional analysis are canceled diagonally. So that means that here we're going to put 1 mole of NH2OH on top Avogadro's number, 6.022 times 10 to the 23rd molecules of our compound, which is NH2OH. So moles of NH2OH cancel on both sides. That means that our left unit is going to be molecules of NH2OH, okay? And that's where the result comes from, which is rounded to the correct number of six figures, which is 3, 5.62 times 10 to the power 23rd. Okay. Let me change back to the Kahoot. Any questions so far? Then let's continue. There you go, 6 in a row. Let's go. Let's move on to question 7. Excellent. People know how to write the or calculate the molar mass for this compound, which is C2H2. Great job, you guys. Let's continue. Ooh, somebody's gonna get a perfect score today. Let's move on to question 8. Great. So let me make sure that everybody knows how to do this one. It's 49.3. Okay, so here we were given grams. Now, the key for this problem was to identify that the word that we were given, it said molecular oxygen. And when we're talking about molecular oxygen, molecular hydrogen, molecular nitrogen, fluorine, chlorine, bromine, iodine, we are referring to the diatomic, which means that we're talking about O2 in this case, okay? So if we're talking about O2, that means that we need to divide here by the molar mass of O2, which means that this is 15.9994 times 2, which is 31.9988 grams for O2, because basically we take the molar mass of oxygen and multiply it by 2, because we're talking about molecular oxygen. And then on top, we put 1 mole of O2. Okay? When we do that, divided by 31.9988, we got this as the number of moles. Okay? Put a 3 in the chat if now that problem makes sense. Let me make sure that for the people that didn't get it, at least now it makes sense. So be careful whenever you see the word molecular and next to it, you have the name of an element that you know is diatomic. Then remember that it's going to have a subscript of 2 because it's diatomic, okay? Let's continue to question 9. Okay, let's review electron groups. So remember that electron groups, which is a topic that has to do with Lewis structures, is just an illustration of, just like the name says, a group of electrons. So when it comes to electron groups, they come in 4 flavors: a lone pair, a single bond, a double bond, a triple bond. So in this question, it says, how many electron groups are found around the carbon atom in the following molecule? So when we look at our molecule, we see that around any of the 2 carbon atoms, okay, we have 3 electron groups: a double bond, a single bond, and a single bond, okay? Please do not confuse that with the total number of electrons that you're going to have around an atom. Most of the atoms in this molecule, meaning carbon and fluorine, they have 8 electrons. That is just part of the octet rule, okay? When I mean with electron groups is, again, out of the illustrations that we can utilize for electrons, which again, they can be a lone pair, a single bond, a double bond, or a triple bond. How many do we have around a particular atom, okay? Put a 1 in the chat if now that question makes more sense. I want to make sure that we understand electron groups. Excellent. Let's move on to the next one. Let's go to question 10. Sorry, that was just worded poorly because it said for the carbon atom and it's for the oxygen. So I apologize for that. But in general, when it comes to looking at electron group geometry, okay? Remember that electron group geometry depends on the electron groups, okay? And the electron groups in this molecule is always around the central atom. So around the oxygen, we have 4 electron groups: a lone pair, a single bond, and a single bond. So taking that into consideration, then you have to say, okay, since there's 4 electron groups, then that means that that is a tetrahedral electron group geometry, okay? I hope that that makes it more clear.
Just a quick question.
Yes.
If we were looking though at the chloride, one of those 2, you would say that there around them are 3 lone pairs and 1 single bond, correct? Okay.
Yes. Which is still 4 electron groups, right?
Yes, but different.
Exactly, but a different flavor of electron groups.
Mm-hmm. Okay.
Good, let's continue. Great job. If you have a tetrahedral molecule, then the bond angle is 109.5. So in this molecule, which is the one that we were looking at previously, because it's tetrahedral, then the bond angle is 109.5, not 180. So what is the electron group geometry that has a bond angle of 180? Let's put it in the chat. Great job. Thank you, guys. Exactly. Linear. Let's continue. Excellent. So the reason why the first one, the one in red, is not polar is because it's a linear molecule that has on both sides attachment to the same atoms. And if you're linear and you have two identical bonds, that means that you're non-polar. The molecule in green is a tetrahedral molecule that has 4 identical bonds. That also makes it non-polar. Remember that when it comes to overall polarity, what you need to tell yourself is, if I have a Lewis structure in front of me, or if I specifically have to draw the Lewis structure, I have to identify the electron group geometry, and based on the electron group geometry, then I ask myself, if the molecule is linear and it has identical groups, 2 of them, that means that it is non-polar. If that's not true, then it is polar. For trigonal planar, you have 3 identical groups, that makes the molecule non-polar. And then in the case of tetrahedral, like we see the molecule in green, then 4 identical groups makes the molecule non-polar. Let's move on to question 13. This is chapter 4. Great. For the 7 people that were able to answer, indeed, this is a ketone. We have a carbonyl, which is that C double bond O, and since we have a carbon chains on either side, that's what makes it a ketone, okay? We're going to do at least 2 more functional group questions, so get ready. Let's continue. Great. As you can see, here we have a methyl, but that SH group in the corner is what makes us be a thiol in terms of functional group. Let's continue. Let's move on to question 15. So this is another member of the carbonyl family. This is particularly an ester, which is a carbonyl. As you can see, C double bond O, that's the carbonyl. And then to one side is bonded to a single bond oxygen, and that single bond oxygen is bonded to a carbon chain. That's what makes it an ester. To the other side of the carbonyl, you could have a hydrogen or you can have a carbon chain. In this one, we have a carbon chain, CH3. But remember, when you have an ester, the main thing to have is a C double bond O, single bonded to oxygen, and that oxygen must be bonded to a carbon chain. Let's continue to question 16. Okay, let's go over this. So only 2 students got the right answer. So how many carbons do we have in this molecule? Let's put it in the chat. How many carbons? In the longest carbon chain, for that matter. Excellent, 4. So that tells you that butane is going to be the longest carbon chain. That butane extends from the CH3 to the CH2. Now, when we're numbering this alkane with 2 substituents that are the same, do we start left to right or right to left? Great, right to left. because we need to start at the end that is nearest a substituent. So our carbon number 1 is going to be the CH2, followed by the other CH2, that's carbon 2. Then the CH that is holding that chlorine is carbon 3, and then that CH3 is carbon 4. So that means that our substituents are on carbons 1 and 3. So that's why the answer was 1,3 dichlorobutane. So be careful when you look at the atoms, especially in alkanes. Question 17. Let's make sure that we practice our naming, you guys. So when it comes to the longest carbon chain in this molecule is going to be 7 carbons. So starting with the CH3 all the way to the left, that's carbon 1. Then the CH that is holding the fluorine is carbon 2. Then you have the triple bond, that's 3 and 4. Then the CH, that's carbon 5. And then we have to go up to the CH2, CH3, that's 6 and 7. So that means that we have 2 substituents, one on carbon 2, one on carbon 5. And since our triple bond is in between carbons 3 and 4, that's why the answer is the red one. Let's move on now to question 18. Okay, I only see that 3 students got this. Let's go over the following question. Let me just take a moment to draw the molecule. So this is the molecule we have. Whenever we're looking at chiral centers, we are looking at the carbon atoms in the molecule. Let me include them. So here there's a CH, here there's a CH, here there's a CH, here there's a CH3, here there's a CH3. Now, the concept of chirality tells me that I need 4 different groups around a carbon atom. So let me number these carbons. 1, 2, 3, 4, 5. This is just to make a distinction between the 5 carbons that we have in the system, okay? Based on the definition that a carbon atom that is chiral needs 4 different groups, let's put in the chat, what are the carbon atoms that are immediately disqualified from being chiral? Let's put it in the chat. Excellent job, you guys. The ones that are CH3s. So that means that those cannot be chiral. So we're done. These are not. So then we have to investigate further on carbons 2, 3, and 4. Okay. So remember that in the concept of chirality, it's kind of like when you go to the mall and you know that there's these maps in the mall that says you are here. And based on that map, then you can see what's around you. Well, you have to make sure that the 4 things around you are different from one another. Let's explore carbon 2. So on carbon 2, we have the following. We have a hydrogen. We have a fluorine. We have a methyl. And then we have all of this of the molecule. Okay. So is carbon 2 chiral? Yes or no? Does it have 4 different groups around it? Great job. Exactly. It is chiral. So what do we do with chiral carbons? We label them with an asterisk. Okay. Let me just erase some of these notes that I have here. Let's move on to carbon 3. On carbon 3, we have the following groups. We have a hydrogen. We have a hydroxyl group. And then we have whatever we have on the left and whatever we have on the right. Does carbon 3 have 4 different groups? Yes or no? Excellent. It doesn't have 4 different groups because you can see that the left side and the right side of the molecule is the same atoms with the same attachments. So that means that carbon 3 is not chiral. Carbon 4 has a similar situation to carbon 2, in which your 4 different groups is going to be the hydrogen, the fluorine, the methyl, and the rest of the molecule. So that's why carbon 4 is also chiral. So taking that into consideration, that's why in this molecule, we have 2 chiral centers, okay? Let's move on to question 19. There you go, Tasia, 4 in a row, great job. Ooh, what happened, family? Let's explore this together. So we have two molecules, okay? This is the thing for finding the relationship of things that are either diastereomers versus enantiomers versus identical, okay? All that kind of good stuff, which this is good for the chapter 5. Let me verify something. Where are my notes? Anyways, I'll explain this problem. So when it comes to this, you need to find out if the two molecules have the same chemical formula. That's the first thing we do. Find if they have the same chemical formula. Once you have determined if they have the same chemical formula, you have to name them. Okay? If you name these molecules, the left one and the right one, they have the same name. Okay? They even have the same conformation in terms of cis and trans. That's why they are identical. Okay, and that's the relationship between the two. Let me double check something because I don't want, give me one moment. So make sure that in the in-class worksheet, you practice this type of problem. This is the last few concepts from chapter 4, okay? So understand that when you're targeting this problem, you have to find the chemical formula for both. I'm going to make sure that you guys can name them. And if they have the same name, then they are identical, okay? Let's do one more of these problems. Sorry that the background, I didn't know that the background was just going to black my, like blend in with my molecules. Let's just say that they're mirror images of each other and both of them are chiral. They're mirror images of each other and both of them are chiral. Great. So sorry, this molecule is not showing them. I don't like when it does this, but if you have two molecules and each of them are chiral and they're mirror images of each other, remember, always the analogy of your hands. They are chiral objects that they're mirror images of each other. The relationship is always enantiomers. For diastereomers, you have two molecules that have same chemical formula, same name, is just that one is cis and the other one is trans. That's just the difference between them. One is cis and one is trans. And then the other one that we haven't seen, which is a constitutional isomer, remember, same chemical formula, but the attachment of the atoms is completely different. So make sure that you practice that in the in-class worksheet. Let's just finish up the last 5 questions in the review. In this chemical reaction, we have a compound that has carbons and hydrogens. We are mixing it with O2 and we're making CO2 and water. Great, that's a combustion reaction. Make sure that you know the 5 different classifications that we went over in the beginning of chapter 5. There you go. Liz has 3 in a row. Great job. Let's move on to question 22. Another classification. We have molecular fluorine reacting with iron 3 iodide. And then we see that in the product, the iodide is by itself. And now the fluorine took the place of the iodine. Great. So that's a single replacement reaction. Great job, Negi, 3 in a row. Let's continue. We only have 3 more questions. So this is the energy diagram for an exothermic process, because we can see that the products are lower than the reactants. In an endothermic, the products are higher than the reactant. This, we cannot say that it has a catalyst because we are not comparing 2 reactions. In order for us to make that statement, we need to compare 2 reactions, one that is catalyzed and one that is not catalyzed. And then the green answer, nobody select, great, because that is also the definition for an endothermic process. It absorbs energy from the environment. Great job, Dominique. 3 in a row. let's go. We got only 2 more questions. Sorry that this extended more than 7:20, but we only have 2 more questions. Great job, you guys. When you have 2 or more elements or compounds that form one product, that's a combination reaction. Let's prepare for the last question. As you can see, these are the people that are in the top 5 spots. The top 3 get 3 points, and then from positions 4 through 8, you get 2 points of extra credit, and positions 9 through 11, 1 point of extra credit. So let's finish up strong. Great. Let me see. Put a 1 in the chat if you want to see how to determine the oxidation numbers for this reaction. Okay, let me just write the chemical reaction. 2 PBS plus 3 O2s, 2 PBOs plus 2 SO2. Excellent. Share screen, icon, share. Great. So this is the chemical reaction that we are working with. So when we go through oxidation number, remember, elements that are by themselves, either just the symbol of the element or their diatomics, they're going to have an oxidation number of 0. So because of that rule, the oxidation number of O2 is 0. PBS and PBO, they're both ionic compounds. If you have an ionic compound, then the charge that each of the elements have is going to be its oxidation number. So for PB, the oxidation number is +2. For S, the oxidation number is -2. Similarly, in PBO, PB has an oxidation number of +2. Oxygen has an oxidation number of -2. Okay. Lastly, SO2, so sulfur dioxide, is a covalent compound. So the way that we're going to determine its oxidation number is by saying, okay, the second nonmetal has an oxidation number of -2. When we multiply it by the subscript, that gives us a total of -4. Since this molecule overall doesn't have a charge, then the addition of the oxidation numbers must equal 0. Since sulfur in sulfur dioxide has a subscript of 1, that means that its oxidation number must be a +4. So sulfur is +4. Our oxygen is -2. So when it comes to this, we write in the atoms that we have, which is PB, S, oxygen, okay? And then we say, what is their oxidation number at reactants and at product? So at the reactants, PB has an oxidation number of +2. Sulfur has an oxidation number of -2. Oxygen has an oxidation number of 0. In the products, PB, in other words, lead, has an oxidation number of +2. Sulfur has an oxidation number of +4. Oxygen has an oxidation number of -2. To determine in this question specifically, which one gets reduced, what we're doing is determining which one went from a positive all the way to negative. So remember, reduction means that you gain electrons. So if you gain electrons over time, your oxidation number is going to get into, wait, I switched this. Give me 1 second, because I did this backwards. This is negative and this is positive. Okay, now the other way around. So as something is gaining electrons, okay, now it's in the right direction. As something is gaining electrons, it's losing positivity and going into negative values, okay? So what we can see here specifically is that oxygen is the one that is going from 0 towards a negative value. So here we have something that went from 0 into negative. That's why it got reduced. So what happened to sulfur in this? Let's just put it in the chat really quick before I let you guys go. What happened to sulfur in this reaction? Great, thank you, Katie. It got oxidized. And then what do we call elements like lead, that did not change the oxidation number. Great job, you guys. Exactly. The spectator ion. They're just looking at the movement of the electrons happening, but they're not involved in the reaction. Okay. So let's see who gained today 3 extra points of extra credit. Remember that you guys also have the Canvas extra credit that you can fill in to gain more extra credit points. Let's look at the podium. Dominique got 3 points. Nikki got 3 points. And Liz got 3 points. Congrats to everybody, because everybody earned extra credit. But these students specifically gained an extra 3 points of extra credit. And remember that you can gain up to 5 points of extra credit with the Canvas assignment that I put for extra credit. Okay. So this is all that I got for you guys today.